All right, this one says find the fifth degree Maclaurin polynomial for the function f of x is equal to sine x. All right, so we know sine does that. We're just wanting to find a polynomial that would help us approximate. I can plug in numbers easier to the polynomial for x numbers around 0. So our center this time is 0 because it says Maclaurin. Taylor polynomials centered around 0, just special Maclaurin polynomial. So I'm going to practice by writing out the general look for a fifth degree Taylor polynomial. That would be equal to f of 0 plus f prime of 0 times x plus f double prime of 0 times x squared over 2 plus the third derivative of 0x cubed over 3 factorial plus the fourth derivative evaluated at 0 times x to the fourth over 4 factorial plus one more. All right, now the next step is write out all the values that you're going to need to plug in here, 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 here. That's what you got to find. All right, so sine of 0 is 0. The derivative of sine is cosine. Second derivative, so the derivative of that would be negative sine. Third derivative would be negative cosine. Fourth derivative, positive sine. Okay, evaluated at 0 would be 1, 0, negative 1. And you're probably going to see this pattern and realize when this happens, when f of 0 is 0, that's just going to be gone. F double prime of 0 is 0, so that term is going to be gone. The fourth derivative is 0, so that term is going to be gone. So this one's pretty easy to write. The fifth degree Taylor polynomial, or actually Maclaurin polynomial, would be f prime of 0, which is 1x. The third derivative is negative, so I'll say minus x cubed over 3 factorial, which is 6. Fifth one is positive, so plus x to the fifth power over 5 factorial, which is, I don't know, 120. All right, there it is. Fifth degree Taylor polynomial, fifth degree, centered around, or Maclaurin polynomial, that would be used to approximate sine of x. Let's see, okay, next one. Okay, this is something I don't remember. I would just kind of like have to write out that last part, that general form of the Taylor polynomial, but it says, this is a little shortcut, the coefficient of the nth degree term in a Taylor polynomial for function f centered around x is c would be the nth derivative evaluated at c over n factorial. Because the only part that's missing is this x minus c to the power of n. So the nth degree term, the coefficient is just that part right there. And this could be a little shortcut. If anything, you just kind of think back to this part, and it's just this right there. Nothing too special. But what it does help you, it says let f of x be a function with third derivative that was the coefficient of the fourth term. So instead of writing it all out, we could just do that one step. So the fourth derivative of x, I gotta find the derivative of this, would be, what's that, 3 over 2? 3 over 2 times 8x plus 2, subtract 1 from the exponent, get 1/2, times the chain of 8. So f, the fourth derivative evaluated at, what's the c number? 2, would be equal to 24 over 2, 8 times 2 plus 2, square root of that, which is equal to 12, 16, 17, 18, equal to 12 square root of 18, which is equal to 12 square root of 9 times 2, 12 times 3 times square root of 2, which is what, 36 square root of 2? And that would be the coefficient of the fourth degree term. All right, so in class, this is where I'm going to give y'all just a whole bunch of time to practice, and you're going to try to do these 5 questions as a table. But we're going to go over all these questions now. Maybe I should make this a separate video, and y'all can check your answer. Nah, whatever. Okay, let f be a function having derivatives for all orders of real numbers. The first 3 derivatives of f at x equals 0 are given in the table. Use the third degree Taylor polynomial around x equals 0 to approximate the value of f of negative 1/2. So, what does that mean we need to do? Use the third degree Taylor polynomial. So I'm going to build the third degree Taylor polynomial. Okay, I think it's just helpful to keep writing this out to get it in your head. So it'd be f of 0, because we're centered around 0, plus the first derivative evaluated at 0 times x, plus the second derivative evaluated at 0 times x squared over 2. Third degree, so the third derivative of 0 times x cubed over 3 factorial. And if it helps you think about this, it's all the same, just do that. But I'm going to this is how I write it. All right, so, okay, it tells us all these numbers when x is 0. So the third degree Taylor polynomial, I'm plugging x on the next step. I could do it right now, but I'm going to plug in f of 0, which is negative 4, and then plus 4x plus 6x squared over 2 minus 8x cubed over 3 factorial, which is 6. So to simplify that and plug in negative 1/2, I'm going to get negative 4 minus 2. All right, so negative 1/2 squared, what is that? Positive 1/4. So I've got plus 6 times a fourth over 2. I'm running out of room. What was the other one? Minus 4 over 3 times negative 1/2 cubed, which would be negative 1/8. All right, so we got to figure out what this is. Let's see. That would be equal to negative 6 plus 3 times a fourth, so what, 3/4? This would be negative 1/2. So minus or plus 1/2 over 3, which is equal to 1/2 divided by 3 be times 1/3, so 1/6. Common denominator looks like it's going to be 12. So what would that be? Negative 72 over 12. That's multiplied by 3, so 9 over 12. Multiplied by 2 plus 2 over 12. So negative 72 plus 11 over 12. I guess that's negative 61 over 12. All right. Next one. Let the fifth degree Taylor polynomial equal to this, okay, for the function around x equals negative 1. So since it's plus 1, it's negative 1. What's the value of f of, or the fifth degree the fifth derivative evaluated at -1. So what I'm going to really use here is my understanding on how this term was built. Okay, this term right here is equal to the fifth degree, I should write 5, evaluated at -1 times x plus 1 to the power 5 over 5 factorial. And what I'm wanting to know is just what is this part? Well, all of this part is equal to -2/5. So I'm going to say f, that fifth degree evaluated at -1 over 5 factorial, 5 times 4 times 3 times 2 times 1, is equal to -2 over 5. So I'm going to solve this. What would I do? I would multiply both sides by this. So f, the fifth derivative at -1 is equal to -2 times 5 times 4 times 3 times 2 times 1 all over 5. Those cancel, and I would get -2 times 4 is -8, times 3 is -24, times 2 is -48. So the answer would be B. That was a tricky one, it's kind of fun. All right, number 3. Let f be a function having derivatives of all orders of real numbers. Okay, whatever that means. The fourth degree Taylor polynomial for f around x equals -2 is given by that, where k is not 0. Okay. If the fourth derivative evaluated at -2 is 2 pi over 3, find k. All right, so we have to remember k is equal to the fourth derivative evaluated at -2 over 4 factorial. When it tells us this part is equal to 2 pi over 3 divided by 4 factorial, that's equal to 2 pi over 3 times 1 over 4 factorial, which is equal to 2 pi over 3 times 4 times 3 times 2 times 1. 2's cancel. I have pi over 12 times 3, 36. So I think the answer is C. All right, and I'm going through these kind of fast. I should really be giving you all a lot more time. In class, I'm going to give you all a whole bunch of time to work through these. But just for this video, you're just kind of catching up. Maybe you should have been pausing before. Oh, well. All right, a function has derivatives of all orders at x equals 0. The nth degree Taylor polynomial around x equals 0. And it's known that f of 0 is 6, p sub 1. So the first degree Taylor polynomial at -1/2 is -4. And the second degree Taylor polynomial at -1/2 is -6. Find the second derivative evaluated at 0. All right, so let's take this part. It tells us, so p sub 1 of x would be equal to f of 0 plus f prime of 0 times x minus 0. And this is saying if I plug in -1/2, I should get -4. So what does this help us? P sub 1 is equal, or plug in 1/2. Is equal to 6. Okay, so I guess it's going to help us find the first derivative. Plug in -1/2. Okay, this is equal to -4, right? This is equal to -4. So I'm going to set that equal. So I've got 6 minus 1/2 f prime of 0 is equal to -4. Subtract 6, get -10, cancel out the negatives, I get 10. 1/2 of this is equal to 10. So f prime of 0 is equal to 20. All right, That's going to help us build the second derivative, or the second order, which will help us find this one. So I need room. I'll write it over here. All right, so P, the second degree Taylor polynomial, I guess Maclaurin polynomial, would be equal to f of 0 plus f prime of 0 times x plus the second derivative evaluated at 0 times x squared all over 2. Let's plug in what we know. I know f of 0 is equal to 6. The first derivative is 20. The second derivative is what I'm trying to find. So now I use this information right here that if I plug in negative 1/2 for x, I should get negative 6. So I'm going to say negative 6 is equal to 6 plus 2 times negative 1/2 plus the second derivative at 0 times negative 1/2 squared, which is 1/4, all over 2. We got to solve that for the second derivative at 0. So what would I do? Half of that would be 10, make it negative. 6 minus 10, 6 minus 10, negative 4, add 4, get negative 2 is equal to second derivative of 0 times 1/4 over 2, multiply by 2, get negative 4, times 1/4, multiply by 4, I get negative 16. So the answer is negative 16. That was a tough one. All right, last one. It says, use the second degree Taylor polynomial around x equals 0 for this function e to the power of negative x over 2 to approximate e to the negative 1/4. All right, so a couple things here. Let's just build out the second degree Taylor polynomial around 0. So it's a Maclaurin polynomial. So f of 0 plus f prime of 0 x plus second derivative at 0 x squared over 2. All right, f of x is equal to e to the negative x over 2. F of 0 is just 1. Okay, the first derivative would be what, negative 1/2 e to the negative x over 2. F of 0 there would be negative 1/2. Second derivative, got the chain rule in there, you get 1/4. E to the negative x over 2. 1/4. All right, so I have the second degree Taylor polynomial would be equal to 1 minus 1/2 x plus 1/4 x squared over 2. And that's kind of ugly. I'm going to rewrite this. It just bugs me. 1 minus x over 2 plus x squared over 8. All right, so I want to approximate e to the negative 1 over 4. So what should I plug in for my x? That's the tricky part. What do I plug in for x? So if I plug in an x number, this exponent needs to be negative 1/4. So what is x if the exponent turns into negative 1/4, right? So I don't plug in negative 1/4 for x because that would be like negative 1/4 over 2. So I'm going to say, okay, what is the actual x number to plug in here if I'm trying to approximate what this is? So I'm going to set those two equal to each other. The negatives cancel. X over 2 is equal to 1 over 4. What is that? 4x is equal to 2. So x is equal to 1/2. So what this is really saying is find f of 1/2. Approximate f of 1/2. So I want to say f of 1/2. Actually, I'm going to write like this. I don't need this as a multiple choice, but e to the negative 1/4 is equal to f of 1/2, which is approximately equal to the second degree Taylor polynomial at 1/2, which is equal to 1 minus a half over 2 plus 1/2 squared, which is a 4th over 8. So now just some algebra to finish this up. Where did my little thing go? There it is. This would be equal to 1 minus 1/4 plus 1/32. Common denominator is 32 minus 8 over 32 plus 1 over 32. So 32 minus 8, is that 16? No, 26. Oh gosh, 32 minus 8, why is it so hard? 24. And 24 plus 1 will be 25, so 25 over 32. All right, there we go. All right, that's it for this video. It was kind of a long one. Hopefully it helped, and thank you for watching. Bye.